Okay, so we're going to take a look today at an example of solving for a couple of equations or a system of equations with a method called substitution. I'm going to go through the method of substitution and try to kind of lay it out as best as possible and as clear as possible in this one here. And then hope to have a couple examples later on of in other videos that go through maybe a little bit more complex examples of solving using substitution. So I want to try to lay it out in as simple a form as possible and just kind of go through the process of how we would solve using substitution. Here we have two equations. We have y is equal to negative x plus 1, and we also know that y is equal to x plus 5. Now these are both linear equations which are going to meet at some point. Okay, somewhere along the line they're going to cross each other and they're going to meet, and so therefore they're going to have a solution to the system. And that solution is going to be the point, the x, y value, where they meet. So let's take a look at how we solve this using substitution. Now I put in there without graphing because graphing is another method that we can use to solve, but I don't want to use graphing for this one. I want to use substitution as it's a different method we can do without using graphing software or drawing anything out. So the first thing that we're going to do, the first step, and I'm going to go through 5 steps with how to solve here. Step 1 is to solve one of the equations for one variable. Okay, that means we want to isolate x or y in one of our equations. Well, if you look at the two equations, we actually already have x and y isolated. Okay, we already have them, we have y isolated in both of them. So y is already all by itself, which is handy in this case here, and we're going to use that to solve. Now, like I said, I'm hoping to do a couple more examples in some videos, so take a look at some other links, but we might need to actually do some algebra to isolate one of our variables, if that is what comes. All right, so that's step 1. In this case here, we don't actually have to do any work to isolate that. Step number 2 is we need to substitute the solved value into the other equation. So what I'm going to do is I'm going to take the first equation here. I'm going to take y is equal to negative x plus 1. Now, I could use either one, and that's fine. But what we know is that in this system, we also know the second piece, that y is also equal to x plus 5. So what we can do is we can get rid of the y, and we can move x plus 5 and replace it. So we have now replaced the one y with a different version of y, right? Or a different value of y. And now we have an equation that we can solve. So we have substituted, okay, and that's the big word we're using here. We've substituted the value we know for y, which in this case is x plus 5, into the other equation, okay? And we have to put it into the other equation. All right, so step 3 now, okay? This is where we're going to get into the algebra portion of it. We need to solve for the variable that is remaining. Now you will notice in that equation that we're given, we only have x now, okay? So we are going to solve for x. What is the value of x which makes this work, okay? So that's what we got to solve for. Well, we're going to go through a couple steps. First thing we're going to do, we need to get our x's together. And so I have a negative x there. I'm going to add x to both sides. That means it's going to cancel out on the right-hand side, and we're going to be left with 2x on the left-hand side. We're trying to isolate x now, okay? So that's our goal in this case here. So we're going to subtract 5 from both sides, and we're left with 2x minus 4. Finally, get rid of the coefficient. Divide both sides by 2. It's going to cancel out on the left, and we're going to be left with x is equal to negative 2. All right, we've gotten our x value now. So we know that in our solution, our x value has to equal negative 2. So let's put this up here, and let's look at step number 4. Step number 4 is we need to substitute the solved variable back into either equation. Okay, so before it kind of depended on which equation we solved for, and then we plugged it into the other one. Now we can take whichever equation we want and solve for our y value. I'm going to use this one right here. Y is equal to x plus 5. It doesn't really matter. I just have a positive x here, so I might as well use that instead of having to do a negative. Just makes it a little bit easier for me. And I'm going to plug the negative 2 in for x, so it goes right there. At this point, this one is fairly straightforward, and it's just adding. So we have -2 plus 5, so our y value is 3. All right, so we know that our x value is -2. We know that our y value is 3, so here's step 5. The x and y values will be the answer to the system of equations. So our answer here is -2, 3. And that is where these two lines meet. That is the point where these two lines meet. Find one variable, use that variable in the equation to solve for the other one. I hope this has helped you. If you have any questions, please reach out. I will gladly try to help in whatever way possible, or you might have a different teacher or person that could help you out as well. Thank you for watching, and all the best as you work on these problems.